Welcome this evening. It's Drew Blazik with Blazonomics. And what we're going to solve the different ways you can solve bonds. We're talking about price, yield to maturity for a bond, the number of payments for a bond, um, and the coupon payments or the per coupon payments per year. So what is a bond real quick before we get, so we're going to create this in Excel. A bond is something that the government would issue on treasuries or bonds that they have to raise money for debt. Corporations do it. Walmart does it, where they want to raise money and they issue debt. They don't want to give part of the company away, but they want to go in debt, just like you taking a loan. It's a similar kind of concept. So what we're going to do is we're going to create it in Excel, and you can save this. So if you want to find out coupon payments, you want to find out a price of a bond, the yield to maturity, the number of payments, you'll have this. You can pull it up and just enter in your information. You always have it. Okay, a couple things about a bond. We have to understand what are the terminology of a bond, and it's very similar to very similar how it's structured, like an annuity or a loan. Some very similar aspects to it, but it has different terms. So what we have first, here's the Excel sheet, what I created. We have coupon payments. That's the first one. So anything in yellow, if you see a yellow, that's something that we're going to solve. So you're never going to enter in something in yellow, like a number. That's something that's going to solve on the right side of it here. So we have coupon payments. These are the variables that we need for the coupon payment. And then I'm going to put an equation in there to solve it. So we're going to do coupon payments. We're going to do price, which is the present value. Those who are familiar with like corporate finance, the price is the present value, which is the value today, what the bond is worth. Interest rate or yield to maturity, that's the overall gain you're gaining from the bond. And then I did this one down here, which does kind of give out weird numbers, which is number of payments. So let's start out coupon payments. We got to understand what is a coupon payment. That is, these are the three variables that you need. You need the payments per year. I originally had it as N, number of payments, but that's incorrect. It's how many payments the bond promises to pay you a coupon payment per year. Now, typically they're semi-annual. That's why I have two here. So semi-annual is twice a year. If it's 12 times a year, you hit 12. If it's 6 times a year, you hit 6. Face value. What is face value? Face value is the amount that you get back at the end of the loan. So if the bond, say you purchase a bond for $800, the face value is the future value, same thing, that they're going to pay you at the maturity at the end of the bond, which could be a year from now, 10 years from now, 20 years from now. But that's the future value. And then the coupon rate is the percentage, annual percentage of the face value you're going to get as coupon payments. So the coupon rate you have to have. This is annual. Coupon payments would be depending on how many payments per year. So whatever the annual total amount is, you would divide it by the payments per year. So what we're going to do is we're going to enter in the yellow here. With Excel, whenever you are starting an equation, you always have to hit the equal sign. That tells you you're going to solve something. So all we're going to do is we're going to pick the variables to the right, and it's going to be, and I'm going to bracket this right now. I'm going to bracket that because I want to put those together. Not necessary all the time, but it's always safe to do that, because sometimes you have a mathematical equation. If you don't bracket it correctly, it's not going to come out correct. So we're going to have, what is coupon payments? It's the coupon rate, and then you hit shift 8, which is that star for multiplication, times the face value. The face value never changes. Face value is what you're getting at the end. Don't get them mixed up with the price. We'll solve the price next. But so you want to multiply it times the face value. Typically it's $1,000 or $100. Typically 1,000. So I'm going to multiply it times that. So far, and I'm going to close that bracket. The coupon payments promised is the coupon rate 4.65%, multiply times the face value, and that's the annual amount you are receiving for a coupon payment for the year. So we're not finished. We have to know how many payments per year there are. So all I'm going to do is hit the divide symbol, and then I'm going to select payments per year. And then I'm going to hit enter. So there you go. It's $23.25 payments twice a year. It happens twice a year. So, and then what's nice about when you do an equation in Excel, once you have it solved, so the reason I put that as yellow, you never want to enter a number in there because there's an equation there. But if it's white, that means you can enter numbers in it. So if I hit 1, that means it's 1 payment per year. That's 4.65% of 1,000, which is 46.50. So then you could change it. You can say 2 payments per year. I could say 12, and it shows you the payments per month. Total you're going to get, multiply this times 12 is going to be it's going to be the 46.50. And then you could change face value if you wanted to. You can change all that, and it's solved right there. So that's coupon payments. Coupon payments is not the total interest or the yield to maturity you gain from the bond, but the promised payments. Some bonds do not have coupon payments, worth noting. Okay, next, we're going to look at how to solve the price of the bond. What is the price? The price is what you value it at. The price is what it's sold at. So we can find out what a bond is worth today by these numbers. Okay. So this is what we want to do here. The yield to maturity represents the interest rate in this example. The face value is what you get at the end of the year. The price is the present value, what we're trying to solve. That's today. We have N, number of total payments. N is number of total payments. N is not the number of payments for the year. So we'll solve that in a second. Payments per year I have there. How many years the bond is matured by. So when we talk about bonds, I don't want to go too much in depth about the terminology, but maturity would say this bond will mature in 10 years. So that would be the number of years. And then we got coupon payments. I'm going to do a little different equation there. So I'm going to solve these two yellows here, the number of total payments of the bond and the coupon payments. And then we'll do an equation for the price. So never touch the yellow after you solve it. So what is the number of total payments? I'm going to say equals, it's the number of payments per year. So it could be 12 or 2. Typically it's 2 with bonds, and it's multiplied times the number of years. So that's 60. So you could change it. I could say, you know what, it's only going to be 2 payments per year. Well, 2 times 5 years is going to be a total of 10 payments. So that's what that solves there. Okay, coupon payments. What is coupon payments? Coupon payments, what we solved up here. So what I'm going to do here, I'm going to do something different, because if you ever worked with corporate finance, ever worked with bonds, there's 2 things that you can enter in. You could enter in an equation that has the coupon rate that we did up here. So if they give you the 2 coupon rate, or they could just give us the annual coupon payment. They could just say, you know what, you're going to receive $300 annually payments from the bond of you owning the bond, and they could just give you that. So what I'm going to do is I'm going to do two different, well, it's 1 equations, but 2 different functions to solve these 2. And I'll show you what I mean. I put an or there, and I'll explain in a second. So I'm going to say equals. So the coupon payment would be equals the coupon rate. Again, I'm going to bracket this, but I'm going to bracket it twice because we're going to have 2 functions in this 1 equation here. So it's going to be the coupon rate multiplied times the face value divided by the number of payments per year. That's important. So it's number of payments per year. So we have to find out what that is, and that's right there is 2, number of payments per year. Okay, so that's the first one. And what I'm going to do here, I'm going to say, no, one thing I forgot. If you look at the equation there, I'm going to bracket this here. So I want this number times this number. And then once you solve that times that, I'm going to divide that multiplication there by whatever the number of payments are. So I want to make sure I close that bracket there. Then I'm going to say plus. I'm going to plus another part of the function here. So, or it can give us just the annual coupon payments. So instead of solving with the rate, someone could say, I'm going to be $300. So I'm going to say 300, but we still have to know what are the coupon payments. That's the annual coupon payments. That's going to be divided by, so the total amount, just like we did here, I'm going to divide it by the number of payments per year, which is 2. Okay, so I'm going to close that up. We have our equation. I'm going to show you what we could do here. So I don't have any numbers here, so it's really these numbers going to work. I put an or there. So if you want to solve it by a coupon rate, if that's what's given, just enter in a certain percentage. Let's say that. Well, then it solved it for you. $22, so 4% of 1,000. What you always want to do as well, anytime with working with Excel, sometimes it won't be have any decimals. When you're doing percentages, make sure you select that cell and you hit up here numbers and go to decimals. If I did do 2 decimals, it's 4. It's still 4.4 in Excel, but it's good to see that. So 4.4% of 1,000 is $44. Divided by 2, so it's 22 is correct. So I put down an or. So whatever you get to solve this price, you had to have one is 0 if you want to do the other one. So I could say, I'm going to have that one 0, that percentage. Now it doesn't give you a number, but I'm going to say, you know what was given to me is $200 of annual coupon payments. So this is happening per year. I'll hit enter. And then it solves the coupon payments. It's 200 divided by that. I could change this and it will correct the coupon payments. Now, if I want to put the coupon rate back in, you got to hit 0. And then I could put a percent, 2.2%. Now it's 1.3 because it's 2.2% of $1,000 and you have 12 payments. That's $1.83 dollars per month because it's 12, or I could just do the semi-annual what it is. Okay, so that's what I did. So I did the or. So when you're solving for a bond, it's either they're going to just tell you, make it easy, or they're going to tell you a percentage. Either way, you have it solved there. That's how the equation works. But you got to make sure, always remember that, have the other one 0 if you're going to plug it in. Okay, so now we're going to go up here. We have everything solved. Now what we want to do is find out what is the price. So we're going to hit enter. Now I'm not going to do an equation. What I'm going to do for the remaining 3 functions we're going to create here, I'm going to say equals. In Excel, this is called the present value. It's very simple. The present value would be the price of a bond. So I'm going to hit the present value. I'm going to select the present value. And then what it's going to do in Excel, it's going to give me step by step what I have to enter in. So this one makes it easy. I have all the variables here, what we need. And now we're going to hit step by step. Now, one of those I have to explain. The number of payments, and second to M, and because I have a bunch of them, I have number of payments per year, and years. So first off, the rate. So I have the interest rate here, 3.15%. You could change it. So when you're solving bonds, always be some rate. It could be the opportunity cost. It could be the cost of capital or some sort like that, or yield to maturity. But I have that rate, so you're going to select that, right? So it's always going to save that box. Now, when you do a function in Excel, this way, you have to hit comma, and then it automatically goes to the next variable to enter in. Now, what is number of payments? When we're looking at a bond, we're not looking at the payments per year. We're not looking at the total years. What we're looking at total payments, which is this N that we solved. Total payments. So I'm going to select the 10. I'm going to hit comma. Now, what are we looking at? We are looking at coupon payments, okay? What is the coupon payments? And that's based on how many payments per year. That's coupon payments. This N is based on total payments. So it's how many payments per year with years. So they're both in the same thing. So if we put monthly, payments per year is monthly. The N is in monthly. It's total months times years. And then this would be monthly as well. It's automatically in it. So we're looking at payments, coupon payments. I'm going to select that. I got the PMT there. And that's asked for PMT. So I'll select that. And then I'll hit comma. Future value, that's the face value. That's what a bond is called, the face value. FV is future value for financial calculators, for annuities. So I'm just going to have to hit this 1,000 here. And then I'm going to hit comma. Now what this is, it's either a 0 or the 1. It means when does the interest start? Does it start at the end of the period, majority of the bonds, annuities, stuff like that? Or does it start at the beginning? So this is a quick example. Sometimes the lottery, for example, they could say, we'll pay you $1,000 each year starting today. So that $1,000 started today, you would say that's at the beginning of the period. But typically we would say at the end of the first period is when you get that interest. That's what we're doing here. So I'm going to hit 0. And then I'm going to hit close up the bracket. And there we go. I'm going to hit enter. All right, a couple things. Remember, yellow, never touch those. Those are equations that are in the yellow. All the white ones we could touch. So I could say, you know what if it goes to 4%, our price changes. If you notice that 8%, everybody knows about bonds. It's inverse related. The interest rate and the price of the bond, as the interest rate goes up, I go to 10%, the price of the bond goes down. If I go to 1%, the price of the bond goes way up. So the inverse related, and it shows that. So you can plug in anything. The face value could change. I could change this. Am I doing? Okay, I could change that. I could change number of payments per year and see if it changes. It does change the value of the face value. I could change the amount of years. Definitely would change it. Longer the years, the price is cheaper because you're getting $1,000 back way in the future. So it gives you other options. You can solve it. Okay, why is number of payments? I always like going back to this. Why is this price negative? The bracket is negative here. Is because anytime you're doing a function in Excel, if the future value is positive, or it has to do with payments as well, typically the present value will be the opposite, be negative. So, but it makes sense because this is a cash flow that you're going to receive at the maturity at the end of the time. How many years? In 5 years you're going to receive that. In 2 years. So in 2 years you're going to receive that 1,000. That's going to be a payment. That's why it's positive to you. The payments, these coupon payments, those are positive amounts. So that's why it's a positive amount. You're getting back. Why is the price negative? Because you have to purchase the bond. This is what you're purchasing it for. So $898, that's what it's going to cost you. And that's why it's negative, because you have to get rid of that money. So there you go. So we did that. And again, everything changes. Coupon rate, I hit 0. And then I can say, you know what, coupon payments, they're going to give me a hefty $500 per year. And you can see it jacked up the price of that bond, because now it's worth more, because not just I'm getting $1,000 back at the end of the maturity, I'm getting $500 every year as a interest payment to me, right? It's a coupon interest payment. So you see I go up. Okay, now let's solve the interest rate yield to maturity. Okay, so we got the face value. Make sure you have the dollar signs correct. Make sure you have the percentages correct. Just note, if you put 9, you go, okay, I forgot to put an interest rate. And then you go up here and go, okay, I'm going to put the percentage in. It'll make it 900, because 0.09 is 9%. So all you do is click out of it. You go back, and once you hit 9, then it goes a percentage. So just let you know, you should probably hit the 9 first, and then the percentage, and then you don't have to double click it. Okay, so we're going to look at the interest rate. I want to solve for the number of payments. So we'll do that again. What is that? That's the number of payments per year multiplied times the number of years to maturity. And then we're going to do the coupon payment again. So I'm going to say the coupon payment is going to be equal to, I'm going to bracket it twice, which is the coupon rate multiply times the face value. And I'm going to close that. I'm going to divide that by the number of payments per year. Then I'm going to say plus, because I can make 1 0, and since they're multiplication division, you make one number 0, it automatically makes a 0, and it only does the other side of the equation. That's why I did it that way. So I say plus, or is given the annual coupon payment. They could tell you how much you're going to get as a annuity payment or interest payment per year. So I'll say that, and you have to divide that by the number of payments per year. And then I'm gonna close it up. There, we solved it. So again, I got the coupon rate here. I can say 3.99%. 3.99. And again, you got to go here. I'm going to make the decibels so we see it's 3.99%. Okay, and I want to show one thing really quick as well. So that equation I have, let's say for present value up here, if I double click on the function, what's kind of cool, it shows everything that's highlighted that was selected for the equation. So it shows that, and then you can actually, what was PMT? You could do that, it's F19, you could find it, PMT, F19, and then you could change whatever, want to do the adjustments on it. So, okay, so we got the coupon payments, we got that. And never put both these in. So if I said $400, what's that saying? That's saying you're getting $400 per year as a coupon payment plus 3.99% coupon payments, doubling it up. So make sure you make one of those zero. Okay, that's fine. Let's solve the interest rate. So how do we solve the interest rate? I'm going to say equals. I'm going to type in rate. I'm going to double click on that. Okay, so we have rates. So the first variable we have to enter in is NPER. That's right here. N, that's the total number of payments throughout the life of the loan. I'll hit that. I'm going to hit comma. Coupon payments, which is solved right there. Comma. Present value, which is the price. So price is something I just kind of threw in there. Comma. What is the future value? That's the face value, what you get at the end of the loan. So that price is what's paid at the beginning. Future value is what you get at the end of the maturity. Maturity is in 5 years. So we got the future value. I hit comma. What kind of loan it is, or end of the period or beginning. I always say end, and then I'm going to close it. Then we'll hit enter. Okay, I got an error on this. And why did I get an error? I think it might be. I just changed that. It just wasn't adding up, that low price. So I had it originally the face value of $100, the $92 price. I switched to 1,000. I got to switch that kind of closer. So there we go. So all you have to do is enter in all that stuff, and you'll get the yield to maturity for this bond. So it's a pretty high yield to maturity. You're earning 25.73% per year on it. Yield to maturity. So that's really good. It's because it's $1,000. It's only costing you 800, and you're gaining 400 coupon payments and all, and you're getting $1,000 back within 5 years. But let's be more realistic here. So I'm going to hit that as 0. And I'm going to hit percentage. Let's say it's 4.65% coupon payments. And then more realistic here, this yield to maturity is 4.9%. And again, you could solve anything, never touch the yellow. Those are equations as solved. And you can play around with it. You can see what happens. What if you extend it to 10 years? Does the yield to maturity go up or down? It goes down. Longer it is, it goes down. And so does that make sense that if I paid for $800 and I got $1,000 next year, I'm making pretty good money, making $200 in a year. But if I paid $800, I'm getting $1,000 back in 100 years. That's really not that good. So as it goes, if you extend it out, it will, the interest rate will fall. Okay, last one. This one's a little different. It's a little weird because we're looking to solve how many number of payments we solve from all those. So the coupon payment, I made it simple. You have to just figure out what it is by itself because you probably would never use this. I'm just doing it for fun. Remember, we divided by n. We're solving for n. So I couldn't solve this by solving for that. It just wouldn't make sense. So I just did coupon payments. You have to yield to maturity, the price, and the face value. So how do you solve for this? Will you ever use it? Probably not. NPER. Okay, what do you have to have? You have to have the rate, comma. You have to have payments, comma. You have to have the price, comma. You have to have the future value. comma, we'll say 0, close it up. And now it's going to give us a negative years to solve this. That's a little weird. You get, so if I change this price, let's say to 900, okay, you do get years. I was playing around with it earlier. Sometimes you don't get, let's say I go to 20. Sometimes you get error codes in this. You got to think mathematically. I got to, maybe I'll do another video on it, why that happens when you do a number of periods. But okay, that's it. Thank you for listening. If you want more of these kind of videos, I love doing finance and economics. Subscribe to the channel, like the video, share it. If you want to send it to other classmates, maybe post it. And under the instructions or the comments of this video, put down what else would you like me to talk about. I like talking about economic and finance terms, loanable funds market, Keynesian model, whatever, classical. Want to know the present value, how to solve it by hand equations, whatever it is. Let me know. Let me know in the comments, and I'll be more than happy to do it. God bless, and you take care.